Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam LTAM. The SULT club has 400 members, all aged 25, with independent future lifetimes. The mortality for each member follows the standard ultimate life table, available at smarturl.it/SULT. Calculate the largest n using the normal approximation such that the probability that there are at least n survivors at age 95 is at least 90%. And here's the solution. So let us write k for the random number of survivors at age 95. For each of the 4,000 persons in the SULT club, not ILT, SULT club, her survival until age 95 is a Bernoulli trial with probability of success, survival being the success, equal to L95 over L25, and from SULT, Standard Ultimate Life Table, that's equal to 21,178.3 over 99,871.1. So this is approximately 0.212056341. Thus, K has the binomial distribution with n equal to 4,000 and P equal to the number we just calculated. The mean of k is 4,000 times the fraction we just calculated, 0.212056341, and it's approximately 848.22536. And the variance of k is 4,000 times p times 1 minus p, and that's equal to approximately 668.3537961. Since k is a sum of 4,000 independent, identically distributed random variables, it can be approximated by a normal random variable with the same mean and variance as k. We are looking for the smallest n such that probability that k is greater than or equal to n is greater than or equal to 0.90. This is equivalent to 1 minus the probability of k being greater than or equal to n, which is probability that k is less than n being less than or equal to 1 minus 0.90, which is 0.10. Therefore, note that we use the standard notation z for a standard normal random variable, and that we are using a continuity correction. 0.10 is greater than or equal to probability that k is less than n, which is the probability that k is less than or equal to n minus 1/2, because we are dealing with a discrete random variable, and of course those two probabilities are equal, but with a continuity correction accounts for the fact that we kind of envision the probability of k being equal to n or n minus 1, any integer value, as a rectangle with the bottom length of 1, with each end of that bottom being at 1/2 between two numbers, and the height of it being the probability, and that's the histogram that we create that way to calculate the probabilities correctly. And of course, being less than n is the same as being less than or equal to n minus 1, and then we put that rectangle on top of n minus 1, centered at n minus 1, but going from n minus 1 minus 1/2 to n minus 1 plus 1/2, which is n minus 1/2. So anyway, it's a standard continuity correction, and it's equal to probability that k minus e of k divided by standard deviation of k is less than or equal to, actually, I should have said here. Okay, so I corrected it to less than or equal to. Now, once we switch to the continuous distribution, the standard normal distribution, which is continuous, it will not matter whether we say less than or equal to or less than. And that's what we plan to do, because the left-hand side is the random variable k minus its mean divided by its standard deviation, and we know that k is approximately normal because it's the sum of a large number of independent, identically distributed random variables. So we replace it eventually by z, and on the right-hand side we plug in all the parameters, e of k and the standard deviation of k. And this is what we get, and that says that probability that z is less than or equal to n minus 848.72536 divided by the square root of 668.3537961 is less than or equal to 0.10. Well, okay, that means that this number that we have is the 90th percentile of the standard normal distribution, which is 1.282, and the 10th percentile is negative 1.282, and because this probability is less than or equal to 0.10, so we are at the 10th percentile. N minus 848.72536 over the square root of 668.3537961 is less than or equal to negative 1.282, or n is less than or equal to 848.72536 minus 1.282 times the square root of 668.3537961. And that's approximately equal to 815.0824069. And the largest integer value of n meeting this condition is 815. And that's answer B. Please remember, this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.